Alright, now I want to talk about solving and inequalities. So remember, and inequalities are the ones where both inequalities have to be true in order to make the inequality, in order to make that number a solution to the inequality. So an example of that again, that we would need to solve would be that negative 50 is less than 7k plus 6 is less than negative 8. So we want to know for what value of k will this be a true statement. So in order to do that, we can follow a series of steps. The first step would be to rewrite this inequality into two separate inequalities. So if we take a look, we can separate out this one inequality into two separate inequalities. So the middle is common ground. So this 7k plus 6 is part of both inequalities. The first inequality would be from the 7k plus 6 and this negative 50. And then the second inequality would be the 7k plus 6 and the negative 8. So if I wrote my separate inequalities down here, then my first one would be negative 50 is less than 7k plus 6. And my second inequality on this side would be 7k plus 6 is less than negative 8. Notice the 7k plus 6 is a part of both of these, a part of this one and this one, because that's my common ground in the middle. So then after we've written them as two separate ones, we can solve each of them. Remember, this is an and inequality, so we can keep that word and in the middle just like the word or is on the other to show both parts, that they both must be true. So as we solve each inequality, it's going to feel a bit repetitive because we are getting rid of the same things on both of these. So just like a two-step equation, just like a two-step inequality, if this wasn't even here, we would solve this by subtracting 6 and subtracting 6. So that would give me negative 56 is less than 7k. Then I would divide by 7 and divide by 7 to make this 1. So then I have negative 8 is less than k. If I flip-flop that around, then that would be k is greater than negative 8. And then I go and solve this one the same way. Minus 6, this is 0. So 7k is less than negative 14. I divide by 7, divide by 7. So this is 1. So k is less than negative 2. Remember, this is an and statement. So this is where I would stop and think to myself, can a number be greater than negative 8? Okay, where negative 8 is, and less than negative 2? And the answer to that would be yes. If you're unsure, graphing is always a great way to check and make sure that that is a doable scenario there with the different ends. We can always rewrite it as a compound inequality. So if I put k in the center, generally when you're rewriting it as a compound inequality, your numbers will go from least to greatest. So that would mean my negative 8 would be on this side and my negative 2 would be on this side. My alligator mouth is eating my k up here on the negative 8, so it would be the same way down here, and then less than here. So I still have k is greater than negative 8 and less than negative 2. If I were to graph that, I have negative 10. Let's write our numbers real quick. So on negative 8, I have an open circle because it is not equal to, it's just greater than. And then on negative 2, I have an open circle because it's not equal to, it's just greater than. And then it's greater than negative 8, so that would mean I shade to the right. And less than negative 2, so that would mean I shade to the left. And so just as we said, this is an and inequality. and all of the values between negative 8 and negative 2, excluding the value negative 8 and negative 2. All of the ones in between those two, but not including them, would be the solution to this inequality. So your answer would be this right here. So for this one, you type a longer inequality. For an and, your solution should still look like an and it should be able to be graphed like an and.